Testing, testing. All right, I'm continuing in Chapter 5 with a preview of your shared student data files, figure 5.7 and 5.8 on page 173 through 176. Your header file for the dollar amount class object definition is on page 175 through 176. And the driver program, figure 5.7, interest.cpp, is on page 173 through 175. Now I'd like to just preview the source code. I will, in the next recorded lecture, dissect the code line by line. I'm pointing out now some highlights of this program and some review topics regarding our class objects and how we trace the logic of the code, as well as how we trace the compiler as it calls a function and returns from a function back to the main program driver. So and I apologize, I'll be moving back and forth between documents, the source code itself, and then my visual, my schematics, my drawings, my charting, my labeling. That's all part of how we're dissecting the code and tracing the objects that are defined, their assignments and reassignments, and any calculations upon those objects. So quickly, our dollar amount object is defined in the $amount.h header file. And our schematic is going to look like the UML. Dollar amount, it is a class object. It's maintaining its own data type of int64_t, which is a long integer data type, allowing us to have greater precision with integers, and we initialize each new instantiated dollar amount class object with amount set to 0. The constructor is going to construct a dollar amount class object with a value of integer 64_t, and you can read more about that data type and its long integer referencing. Each dollar amount class object will have a public access to function add, member function subtract, member function add interest, and member function toString. Now we are familiar with functions. We've been using them up to this point. What's different in the add function, we are passing a dollar amount class object. Now in the past, we've just been passing integers, maybe characters, maybe doubles. Now we're passing the class object, and the class object itself, as we know, always maintains its private member data items and their assignments. Every class object always has access to its public member functions. And we're using write. For some reason, you could call that any variable name you want. It's a variable reference to a class object that's being passed to the add function. And there's examples of subtracting. We're manipulating class object values and making reassignments in subtraction. And the subtract member function expects that a dollar amount will be passed to it. And we're using a variable name locally as write. Write is a dollar amount class object. And it's, again, a variable that's temporary to the body of code in which it's defined. So it lives within the add, open, and close braces, and then is unknown to the compiler. Subtract, right, is a local class object of type $amount known within locally the subtract member function, so the begin and end close brace. Add interest is a public member function available to any $amount class object, and it too has local variables of rate and divisor, and both of them will be of integer type. They are local identifiers known within the begin and end brace of this method. And then our toString, and we'll dissect that code pretty carefully in this lecture and also in the next lecture. Well, then in our driver program, I want to look at the main, begin, end. And we're first going to begin with the first statement in main, and that's going to instantiate a new $amount class object referenced by D1. And with the braces, we're initializing it to 1, 2, 3, 4, 5. So we're instantiating a class object. Its name is D1, and it's maintaining its own amount. And that amount is known throughout the duration of the life of the object. Every class object knows its own data member values. And we're declaring that it's going to be initialized to 1, 2, 3, 4, 5. We are also instantiating another $amount class object named D2. And it resides in current memory somewhere where allocation is sufficient to maintain the assignment of an integer 64T. Capacity. And we are declaring it to be 1576. Now, the comment here is that we're referencing $123.45 as an integer. Now, that's an important concept in this program. We'll be manipulating monetary values as integer assignments for the assurance of exact calculations and results. What this means is that we are constantly maneuvering dollars and cents, our monetary value, to its integer equivalent. And $103.45 is actually 12,345 pennies. Remember that $1 is equal to 100 pennies. So $1,000 would be equal to 1,000 times $1, which is actually 100 pennies. So 1,000 times 100 pennies would be 100,000 pennies. So we're working with this conversion to convert monetary values, which has decimal precision and can lead to inaccuracies in calculations. So the theme or thrust behind this program example is that we're converting monetary values from a decimal precision to an integer precision by adjusting from a dollar monetary value to an integer pennies value. So next, I'd like to skip ahead. And again, I'm just trying to preview these two programs. We'll dissect line by line in the next recording. Skip ahead to, I'm in the driver program, line 13. and we're going to trace the output. So we're going to trace the output from line 13, which is in our driver program. And line 13 is our output statement. We're going to output quoted material after adding D2, notice the closed parenthesis, so a space and close parenthesis. That's the end of my quoted material. And then I'm going to see out D2.toString, and whatever its value is, I'm going to print. And then I'll quote, open quote, space into D2 with a close quote, and continue with this line output. So right now, the compiler is being asked to do something. Do the task D2.toString. Now, at this point, D2 is our object, dollar amount object, and D2 as a class object knows its own class data members. So it knows that its amount is 1576. So with D2 in hand, we want to remember that D2 is now the object in hand. We're taking it with us as we call the toString method. And toString is a public method known by all dollar amount objects. So D2 can make use of its public toString method, which is going to return a string. So we're now calling and now these are my notes. Here's my output line, which is going to be the output to the screen device. Now I'm doing chicken scratching. This is my cheat sheet work. I'm going to call D2.toString. Now D2.toString is called from line 13 in our driver program, but it is a member function of our header. So I'm really at toString line 35 in my header file. So with D2 in hand, I'm going to the class object header file. I'm going to make use of the string toString beginning at line 35. So I'm calling the dot header, and these are my notes again, the dot header line 35, D2.toString. Now what happens in that method? We're going to declare a variable of dollars of type string. So I'm in the header file, line 35. Again, these are my notes as I'm tracing the output. a local variable of dollars is being assigned. Local variables reside in current memory and are known for the duration of the open and close brace within the body of the code that they're assigned in. So this will be known now as dollars as long as we're working and operating within toString. So I've declared dollars as a local variable, and I'm going to initialize dollars with the braces to a string after I calculate amount divided by 100. So I'm calling d2.amount because I have d2 as a object in hand. That's the original calling, d2.toString. So d2.amount is pointing to toString, and I'm expecting an amount divided by 100. Now, amount again is known just to this toString statement, but I passed d2's amount, and d2 as a dollar amount class object knows its own balance, which is 1, 2, 3, 4, 5. Or d2, which is 1576. d2's balance is 1576, and I'm going to divide by 100. Now remember, this is integer arithmetic. So 100 goes into 1576 one time, 5 times, the remainder. And all I'm interested in is the integer portion of the quotient. Remember, use a modulus operator to capture the remainder. So now dollars is assigned 15. I'm done with that statement. I've initialized dollars. So I'll go to the next statement within the toString, and I'm going to declare a variable by the name of cents as a string. And to calculate and assign it, I'm going to use the toString. I'm asking for the absolute value of amount percent 100, which is modular arithmetic, to capture the remainder. So assigning cents, I'm going to initialize it. This is my assignment, my sketch, my tracing of the code. Remember, percent, we're asking for the remainder. And amount, we share D2. D2 knows its own amount. Looking at D2's current amount, D2's dollar amount class object is maintaining amount at 1576. Integer arithmetic, I have 100 goes into 1576. You know, it goes 15 times. With a remainder of 76. And that's what I'm capturing this time, and that's what I will assign to cents. So now we have within D2.toString the local variable dollars and the local variable cents assigned to their values. And what I am working on accomplishing is that we're picking off the dollars of all of those pennies, and we're picking off the cents of all of those pennies. And now we're going to return, remember return, we'll return a string, the dollars amount, and the current dollars amount is 15, to our continuing tracing of the output at line 13. And it's going to return a period, quoted period. Continuing, it's going to output cents.size. Now, that's a new function that we can make use of when we include our C.math and our toString include header files. Cents knows its own size, and its size is 1-2 characters. 7, 6 would be 1-2 characters. So the size of our cents identifier is 2. This is our ternary logic. Is 2 equal to 1? No. So we'll follow the false path and do nothing. That's quote, quote, do nothing. And we'll continue to output cents. And cents is currently 76. We have completed and are at the end of our toString method. So it will return us to the calling environment. And the calling environment is line 13. Line 13, we've output toString as 15.76 converted to monetary value. We have an open quote. We're going to continue with the close quote. There's a space into D1, space, and an open quote. That's the end of that string. And now we're going to convert D1 to string. So we have a call to D1.toString. I'm tracing them, D1.toString. Now I have an object in hand. It's calling its own toString method. D1 is a dollar amount, and I'm going to call its toString method. It's a public method known to all dollar amounts. D1.toString. In the header file, toString begins on line 35. ToString is a member function. It's going to return a single string. I'm going to declare dollars. So dollars is a local variable. It will reside for the duration of this function. I'm going to initialize dollars to its starting amount as a string, amount divided by 100. Now remember, we're sending D1 amount is 1, 2, 3, 4, 5. Integer arithmetic divide by 100 would be equal to 123. We're integer quotient only. Remember, we capture the remainder in integer division with the modulus operator, the percent sign. So dollars is assigned 1, 2, 3 as a local variable. Continuing with the toString method, we're asked to declare cents as a string. This is a local variable. It will be known only through the duration of the two-string open-close brace. And we're going to initialize it with the braces to a string. We're looking at the absolute value of amount percent 100. That's integer modular arithmetic. We're going to capture the remainder of the object that we have in hand. Now we're calling D1, and D1's dot amount is 1, 2, 3, 4, 5. And with modular arithmetic, we end up with capturing the remainder at 45. So now we know dollars is 123 and cents is 45. We're continuing in our two-string method with the next line. We're going to return dollars. Dollars is 123. So we're returning to line 13, 123. We continue with the period as a quoted output string. We're going to continue to output. We're going to check the size of cents. Cents is equal to 45, which is 2 characters. 2 characters. Cent size is 2. Is that equal to 1? No, so we'll do the false path, which is nothing, and continue to add the value of the local variable cents, which is 45. That is the end of the two-string method. So we return to line 13, called from our driver program. I have D1.toString returned. I'm going to quote final close parenthesis, a comma, and then D1 equals as quoted material. I'm going to call D1.add and we'll be looking at this method in the future when we continue with this lecture in a different capacity. Here we'll be adding the current value of D1 and D2 and reassigning D1.amount to that sum. So this first part of our interest.cpp driver, lines 1 through 20, is just a demonstration of manipulating class objects of type $amount and we do adding and a subtracting scenario or two so that you can begin to trace, as I did, what's occurring with your dollar amount class objects, and practice how the compiler calls a method and returns from that method. So we called d2.toString. The compiler is temporarily suspending execution on this line and calling the toString method in the header file. So we continue, and the compiler continues to process the toString until it's completely done, and then returns control back to where it called that method from. So tracing the compiler's actions as it calls a method, executes that method, and then returns to the calling environment. I'm going to leave that portion to you to continue to dissect and analyze on your own. And then pointing to line 28, I just have inserted a comment here that we're beginning now to actually make use of a real life compound interest calculation program. And so we start out with a reminder that we're converting our decimal values to their integer values. So 2% is actually 2 divided by 100. 2.3% is actually 23 divided by 1,000, and so on. So we're giving directions and prompts to the user to make this conversion. And so when they enter 2%, they're going to be entering 2 for the rate. And when they enter 2%, they'll be entering 100 as the divisor. So in our example, we're ready to accept from the keyboard the user's input, and we're going to assign locally, we are going to assign a variable rate and divisor. Through variable input via the keyboard. In our driver program, rate and divisor, and we're going to assign the rate of 5. And if we're assigning 2% or 5% or 7%, our divisor would be 100. So those are local variables known to our main driver for the duration of this program. And then I'd like to continue to preface line 37. We are declaring a new dollar amount of balance. It is a dollar amount object. It knows its own amount, its own data members. We're declaring it to 100,000. And remember, the comment is here that we are, for accuracy purposes, converting monetary values to their equivalency in pennies as an integer variable type. So $1,000 would be 100,000 pennies. So keep that in mind. We do some output, and we output the current balance amount converted to its monetary value. And then we begin to work on our output per year, indicating the amount of interest earned. So we're going to output year, and with some tabbing, we're going to output the column headings of amount on a deposit. So we have year output and amount on deposit, and we're going to output the first year, number 1. In our for loop. For int year 1 is initialized to 1, 1 is less than or equal to 10, so we'll continue the body of the loop. We'll increment year to 2. And we're going to call balance.addInterest. So we're calling balance.addInterest from line 46. So we are in line 46. We've output this much, and we're going to call balance.addInterest. So with a balance identifier in hand, balance knows its own object's data members, balance.addInterest. So this is calling my header file, line 25. Balance.addInterest. And line 25 is the file. Add interest and expecting an integer rate and an integer divisor to be sent to it. So I have balance dot add interest. It expects a rate, integer type, and a divisor integer type. And sure enough, I'm sending my local value 5 to rate and my value 100 from my divisor to this method. Rate and divisor will be local now, local identifiers to this method. I have local variables. Remember, they're known only for the duration of the open-close brace in which they're declared. Rate, which is 5, and divisor, which is 100. Next, in add interest, I'm going to declare and instantiate a new dollar amount by the name of interest. I'm going to initialize it with the braces to this amount. So I'm going to initialize a new identifier of type dollar amount, and it's going to be initialized to amount times rate plus divisor divided by 2, close parenthesis, divide by divisor. So in the add interest, I have a new dollar amount of type interest. So it knows its own amount, data member value, as I am getting ready to initialize that amount. Well, we're calling this with balance in hand. So balance pointing to its amount. It's not preceded by any other object name, so I know it's going to be balance. If I wanted to look at D2 dot balance, then I'd have to preface that as D2 dot amount. So balance knows its own data members, its amount times rate. Balance's amount at this point is 100,000 times the rate, locally known as 5, plus divisor, locally known as 100, divided by 2, and divide by divisor again is locally known as 100. This is all integer arithmetic. So I have 500,000 times 500,000 plus 100 divided by 2 is 50 divided by 100. That'll be 5,000,050. 500,000 50 divided by 100. Now that's integer arithmetic again. Goes 5 times 0, bring down the 0, bring down the 5, bring down the 0. So I have integer arithmetic. The integer remainder is, the integer quotient is 5,000. And that is what we're going to assign to our interest dollar amount object since we are initializing it. So we'll assign interest dot amount to 5,000. We have completed the initialization of our new dollar amount object interest. And we go to the next line in the add interest method, and it's going to call add and send interest. Add is a member function of dollar amount, so we'll go transfer suspension of the compiler to the add method, which is add dollar amount right. So our add method is called. We're sending a dollar amount to right. Remember, that's going to be a local variable within the add method, and we were sending interest. Our statement was call the add method and send it interest. And interest is a dollar amount, so that's okay. And locally, right will be pointing to the interest object. So now in the add method, we are making a reassignment amount plus equals right dot amount. Remember, we have balance in hand. So our statement amount plus equals right dot amount. Amount is with balance in hand. We are still working with the balance object. And the balance amount is 100,000 pennies plus equals means that we're going to reassign amount to amount plus right.amount. Right is pointing to interest, and the interest object knows its own amount of 5,000. So amount, balance.amount is assigned 10500. Balance.amount is going to be added to right.amount and reassigned to one. One more zero there. 100,000 plus 5,000 is 105,000. So our balance is now reassigned to 105,000 or 1,000 pennies. So we are done with the add interest. We're done with add. We've made that assignment to balance.amount. We return to the add interest statement that called add method, and we're done there. So we're going to return to our output line, the driver method. And display the year, which is our first time through the loop, and balance.toString. Now with balance in hand, balance knows its own amount. We're going to call it toString method. And remember that the toString method converts pennies to its monetary value reference. So 105,000 pennies is going to be converted to 1,000 $50. So in the first year, with our principal of $1,000, with interest earned, we have $1,050 in our account. And the output is run on your page 174. This business, we are just testing, being able to add and subtract, manipulate objects, and then we begin with the compound interest calculations as a real life scenario. Printing the prompts to the user enters 5 and 100, indicating 5% and a divisor of 100. The initial balance was 1,000, and in year 1, we output the amount of principal plus interest as $1,050. Now, again, this was meant to be a preview of your next recording where I dissect line by line your shared files, figure 5.7 and 5.8. Thank you very much.